Okay, so question 4 tells us that benzene reacts with N-chlorobutane to give the mixture of products shown. So we see that we get what we might naively expect to be from a normal Friedel Crafts alkylation reaction. And over here we have what looks to be a rearranged Friedel Crafts product. So right away we should start, that should kick in to make us remember that the electrophile in this case may be a carbocation. And carbocations have a tendency to rearrange if they can form a more stable carbocation through rearrangement. Asks us then to provide a mechanism to explain these results. Furthermore, we have which product would you predict to be the major product and why. I've highlighted these because it's a good idea to underline in the question everything that's asked so that when we're done we can make sure that we asked all of the questions that are here. So as you can see, I've started off. How do we start off a Friedel Crafts reaction? Well, we have a catalyst, and it's a Lewis acid, and it reacts with the alkyl chloride to form a Lewis acid base complex. That looks like this right here, and we can put that in place. So there's our Lewis acid base complex. And what happens from that? How do we get the rearranged product? Well, we actually don't form primary carbocations in this case. It seems very unlikely. But we can get a rearrangement of our Lewis acid base complex. We see that this pair of electrons between the hydrogen and carbon reorganize so that our hydrogen migrates as a hydride over to this center, leaving here the carbon 2 in this case electron deficient, and the electrons that are in the carbon chlorine bond reorganize, pop up on chlorine, and we will get the AlCl4 minus anion and our secondary carbocation. So those are the reactive species. What happens from there? Uh, both of these compounds can act as electrophiles, is what ends up happening. So we see I've put down here then what happens to the reaction. Our first reaction we're going to look at is how do we form this? Well, here's our nucleophile now, and this is our electrophile, and we have to reorganize the electrons. We're going to form a carbon bond between one of the carbons on our nucleophile, and in this case, the carbon that is directly attached to the chlorine of the Lewis acid complex. And we can push our arrows to get that. I've just rearranged this a little bit. There we go. We get this attack. This carbon is going to form a carbon-carbon bond between what is now the aromatic ring and this carbon. And when that happens, we also have to, get rid of the carbon-chlorine bond. So the electrons in the carbon-chlorine bond are just going to get promoted up and result in a lone pair of electrons on that AlCl4 anion. What happens over here? Very similar. Our electrophile now is a discrete secondary carbocation, and we can just simply attack that carbocationic center and form a bond between carbon on the ring and the carbocation center in this case. And we end up getting our products. Now notice that I've done this such, I didn't go through the mechanism. The reason I have two arrows is there's intermediates here. That's the rhenium cation intermediate. And just to finish things off, let's throw up our AlCl4 anion. We got to remember that we formed that. And in our final products, also we have regenerated the Lewis acid catalyst. That's because it's a catalyst. So just to be complete, let's throw this up over here. And let's just put a box around this whole thing just so that we can separate our mechanism. That's our entire mechanism, and this is the start of that mechanism.